Welcome to Parsa TV guys, I'm Deniz Küçük and today I'm going to show you crankshaft deflection measurement in commercial ships. Alright, let's getting start the crankshaft deflection measurement. In crankshaft deflection measurement, it's aimed to see if there is bending in the crankshaft. Main engine crankshafts on ships have different millimetric bending rates for each cylinder. Static and dynamic methods are applied for measurements of crankshaft deflection. Deflection gauge is used as a classic method. Strain gauge method is applied as modern method in terms of the continuity of the merchant ship. Hyundai MAN BMW 6S17MC diesel engine examined as an example in this research. According to the manual of the engine, the measuring limits of the deflection were determined. One of the reasons for these bending rates is due to the deviation of the crankshaft and main bearings from the same center line of the propeller shaft and bendings. Deviations of crankshaft bending causes the height and lowness, resulting in the following bending problem of the crankshaft by overloading the bearings. So in this picture, you can see crankshaft below. External reasons. External reasons for measuring deflection on ships are usually made after any collision, grounding, load slip, large engine room fire and bearing failures before and after dry dock. So in these pictures from up to down, you can see the first picture is renewing a crankshaft at dry dock. Second picture is entering crankshaft to the ship, and the third photograph is a ship collisions to another ship and it makes crankshaft damaged. Bearing failure. In case of main bearing failure, the engine is stopped. The reason we stop is to avoid further damage to the shaft and main bearing. Main bearings should be checked and damaged ones should be replaced. The caps inside the main bearings are replaced with lower caps and upper caps, the case of wipeout of the main bearing. Internal reasons. Internal reasons are effect of temperature, hot engine rooms, heat exchange between the cold seawater, when the propeller shaft is not in the line, when the ship is over-trimmed or trimmed between bow to stern, tendency, or when ship loaded and ballasted. Time limits of deflection. Crankshaft deflection measurement is taken every 3000 hours. Chain case and crankcase inspects every 2000 hours. Deflection measured when ship should be afloat, in example not in dry dock, and in calm weather. Time limits of deflection. When we take the crankshaft deflection measurements of main engine, trim from bow to stern, sinking difference should be measured and written. Important things for deflection. During crankshaft deflection measurement, those events should not be done. The ship should not lie on the starboard and port side. It should be recorded how much level and in which tank there is ballast in the ship tanks. Vessel must not take cargo, water or bunker. The indicator valve of which tube crankshaft deflection measurement must be open. Being closed valves may affect the values. Methods for deflection. There are two methods applied for crankshaft deflection measurement. First one is classic method. In this method, the main engine must be stopped and it takes long time to take measurements with dial gauge. Modern method. In this method, deflections can be measured continuously while engine is running with strain gauge. Modern methods. In modern methods, deflections can be measured automatically and continuously while engine is running with strain gauge, which connects to the crank web is connected to the shaft with a precise bend. Strain gauge is smarter and more efficient than dial gauge to take crankshaft deflection measurements. Classical methods. In classical methods, dial gauge must be read before crankshaft rotates. In classical methods, the main engine must be stopped, and it takes 2-4 hours for engine and 15-12 minutes for each cylinder to take measurements manually with drill gauge. So in this video we can see how to take crankshaft deflection measurement in classical methods. Alright, let's go. So in this video you can hear turning gear volume from behind, so it rotates the crankshaft. Drill gauge. The drill gauge should be calibrated to 0 by placing at the end of crankweb weights. The crankshaft continues to rotate 316 degrees. At 10 degrees or 20 degrees, the hand on the drill gauge deviates. This deviation varies depending on the bending on the crankshaft. Crankweb's rotations. As the crankshaft rotates, the drill gauge is read positive and negative from calibrated measure. When positive, crankwebs are opening, and when negative, crankwebs are closing. The drill gauge must be placed between the crankwebs, and when rotates full torque, drill gauge should show us the deviation between crankweb weights. The limit values of crankweb readings are specified by the engine manufacturer in the deflection section of the instruction book. That means you can see crankweb values in manual. Crankpin rotations. When the crankpin is at bottom, crankwebs opened. When the crankpin at top, crankwebs closed in case of crankpin rotations. Openings and closings of crankwebs. As the engine rotates, the openings and closings of crankwebs increases or decreases the height to other bearings. For an example, if we take a short wire and bend it from the same place at time, then after a while the wire will be break. As a result of these openings and material fatigue in crankwebs can cut the crankshaft. This is a rare occurrence on ships. And end of the slide. Conclusion. In classical methods, the main engine must be stopped, and it takes long time to take measurements manually with drill gauge. In modern method, deflections can be measured automatically and continuously while engine is running with strain gauge. Consequently, bending was detected in the crankshaft. It was decided to replace the crankshaft. Thanks for watching. Have a nice day. Peace out.